Hello and welcome back to Statistics 1, Section 9.2 on the critical value approach to hypothesis testing. In the last lecture, we said that we have established mean for something, and we would like to challenge that mean because we have reason to suspect that the mean that we are proposing is better than the one that exists. So we said that the null hypothesis is the one that is currently in place, which was H0. And then we have alternative hypothesis, which was HA, and that's your new mean. So in general, you have the hypothesis that mean is some mean 0, and then the alternative hypothesis had these three possibilities that you can claim. One possibility is where you would just say, no, your mean is wrong, but you are not providing anything, right, to say the mean should be this, or it's bigger, or it's smaller. You just say you're wrong, right? Social justice, right? And then you have the constructive ones where the mean that you are proposing is either larger or smaller than the mean that is currently in place. So these are the possibilities that we established last time. And the first lecture was only to introduce the terms and the type of error that we can make if we don't follow the rules. So these guys had names, and I have to put those names again. So this one was two-tailed. This was the right-tailed. And this is the left-tailed. Test, okay, you can include the word test. And I'm going to get an example so we can immediately see the way this works. So Jack tells Gene that his average drive of a golf ball is 275 yards. So null hypothesis in this case is that mu is 275 yards. That's the null hypothesis because Jack said that his average drive is 275, right? Average means mean, right? So null hypothesis is the claim, and that's Jack. Now, Gene is skeptical, and Jack hits 25 drives, result in yards, and then they take the data. So, because Gene is challenging this idea of 275, Jack goes and hits the ball 25 times, right? It's golf. Gives the data, and the sample mean was 264.4, so X bar is 264.4 yards. And they're looking at the 5% significance level. So At the 5% significance level, do the data provide sufficient evidence to conclude that Jack's mean driving distance is less than 275 yards? So this is what Gene is saying. Alternate hypothesis is that the mean is actually smaller than 275 yards. Now, why is this proposed? Because the sample mean was smaller than the value that was claimed before. So now we have this information, and we're going to perform the hypothesis test to see whether we keep mu equals 275 or we are changing mu equals 275 to something that is smaller than 275. So that's the goal. So you can just say it's wrong, you can say I'm looking for a smaller number, or I'm looking for a bigger number. So now we have this sample mean which is smaller than 275, and that's almost 10 yards smaller than 275. So there is a reason for us to actually push for this idea. So on your homework, you have to do these things in stages. So you see that I have defined null hypotheses and alternate hypotheses. They will ask you to do these things, and clearly we are using less than in this case because this mean that we actually did as an experiment, right? The mean that we came up with in the experiment on the sample of 25 hits was smaller than 275, so we are claiming less than in our calculation. So now, obtain the criterion for rejection, which means do the problem, do the calculations, and then we'll see what goes from there. Now, just looking for another piece of information that is another piece of information that we need that was not given in the main text but later is that the population standard deviation is 20 yards. So that's another piece of information that you need to have in order to be able to calculate all of the things. So I had to go because the problem is all over the place the way it was written. All right, so you have one person claiming the mean, the other person wants to dispute that, and the specs are that the x bar is 264.4 and the standard deviation is equal to 20. So what can we calculate from this? From this we know that our mean of means is the same as the mean, which is our mean 0, which is 275. And we also have our sigma x bar. It's a terrible sigma. There we go. Sigma x bar, which is the calculation we know from before. You take sigma and you divide by square root of n. So that's 20 divided by square root of 25. 20 divided by 5, which is 4. So now we have the sample mean and the sampling standard deviation. So from here we can obtain the z-score. We can obtain the z-score, and the z-score, if you remember, it was x bar minus mu x bar divided by sigma x bar. So we have the 264.4 minus 275 divided by 4. And that works out to be negative 2.65. Now it's time for us to draw. First, it's level. So I need to obtain the value for that. And then I have, well, let's first see what the 5% significance level is when you convert. Is equal to the area of 0.05, because these areas, when the z-scores are in question, are all to the left. Then we use the chart to convert this into the z-value, which would be the z-value that is going to be the cutoff point. And then the other z falls in the... So, okay, let's first convert this. So we go to the chart, which is, we need a z-score chart. For 0.05. 0.05 is in the middle of these two, so negative 1645. So negative 1.645 is the z-score of the significance level, and that one creates two regions, a rejection region and a non-rejection region. And now all you need to do is to look at the other z-score you calculated, and that one is going to fall into reject or do not reject. So this region here, you know, I'm going to move this value. Let's say if this is a 0, and you have 1, 2, 3, let's say 1.6 something should be here. So that's my number, and that's the cutoff, and this cutoff is creating reject and do not reject. So these z-scores, right, are normalized amount of yards that you hit the ball when you play golf. So we do not get to reject the old mean if your z-score falls anywhere in that area. But our z-score that we calculated is negative 2.65. Negative 2.65. And that's in the rejection region. So we have to reject the claim that the mean is 275. So this is how you scientifically take down something that is known as statistical, right, fact. You actually have to have data that supports the rejection in terms that the other mean was bad and we have a better one, and that better one is the one that we get to use to describe this same whatever we're observing. So one more time, the procedure. You read the problem, you establish the ruling mean. That's the null hypothesis. Then you go and you look at the alternative hypothesis which could be in one of the three cases. And then you go and get the rest of the stuff from the problem. This calculation here is the calculation that is serving the challenging party, all right? And this calculation here is the calculation that is going to provide us with the information, or the cutoff point in which this z-score is going to end up on one or the other side. See, if the z-scores worked out on average to have larger than 275, this z-score would be a higher number, maybe even positive, right? And in that case, it would graph here showing that the other mean was at least okay. We don't reject it anymore, right? But we had a high negative number, negative 2.65, which falls into the rejection region. And that means that we need to, I'll write it in blood, we need to reject mu equals 275 in favor of mu is less than 275. And guys, the only one that you have so far is that sample mean of 25 that you did, well, that you collected data and calculated, which is 264.4. So that's the best you can do for now, until you do more survey, right? More testing to come up with more numbers. Let's take a look at another homework exercise. I want to see if we can find a problem that is from both ends. Really? Literally 13 homework examples on half a page for 9-2. That's it. 13 exercises on half page. You think I'm joking? So that means that your MyMathLab will probably have a half a problem to do, because you know how when the book has 30 exercises, your homework has 2, right? So that's the homework page. It's half a page. What they have there as homework is literally asking you to compare which number is bigger and which number is smaller. That's what they have. You need to look at this picture here and say that 9.3, because that's what your homework is. Bye.